Recall that we're telling the story of the Earth, and one of the things any good story has is the passage of time. So we're going to be going through the section on geologic time now. Recall the geologic time scale. We've talked about this. This will be at least the third or fourth time if we count the time in lab as well. Back here in the Precambrian time, not much in the way of hard parts, just mushy organisms, nothing that got preserved in the rocks much. In the Paleozoic time period here in the gray was the time where the early life, paleo means old, and zoic means life, so old life like shells and bones and teeth and stuff like that appeared and get preserved in the rocks. Within that time period is Ordovician, which is right under here at the University of Dubuque, and the Silurian, which is out underneath the airport. So these two time periods, Silurian and Ordovician, are important to us here in Dubuque. And this last one up here, Pleistocene, which is the time of the glaciers, is also important. It sort of put the skin over Iowa. Then it ended about 10 to 20,000 years ago and moved up into the present time period. The Paleozoic ended with the rise of the reptiles. The dinosaurs dominated during the Mesozoic, and during the Cenozoic, the mammals dominated. Whoops. So we don't have any dinosaur fossils here in Iowa because the land was above sea level, and so instead of getting deposition of sediments, we got erosion. So any dinosaurs that died got washed away or eaten up. But there are other places where they've been preserved, evidence of them. I used to teach at the University of New Orleans for 15 years before I moved up here. And the old guys who had started the geology department had done some work down the Yucatan Peninsula in Mexico. This is the Yucatan right here in South Mexico, sticking up into the Gulf of Mexico. Al Weedi in particular was one of the professors who had started the department, done his dissertation work down in the Yucatan area, has had a couple other people in our department, and had maintained contacts down there. He got into the culture so much that he could speak the language enough that he would pass as not only Mexican but as from the particular area that his wife is from. Met his wife as a teller in a bank where he used to go to cash his checks, brought her back to rural Mississippi, working at the University of New Orleans right across the state line. So you imagine the cultural shock there, and maintained contacts down in Mexico. Now, Mexico, the oil is dominated by Pemex, one of the nationalized Mexican oil company. And so Pemex had drilled in the area of Yucatan Peninsula looking for oil, but hadn't really found anything. When they drill, they typically drill a column of rock out so they can look at the rock to see what the geologic history of it is, and to kind of figure out what happened in the past and whether or not oil is present. So when they take those columns of rock out of the ground, thousands of feet down, cut them in half, and slab them up, and look at the inside of the rocks, well, half of them for the Yucatan Peninsula area were donated to the University of New Orleans because of Al Weidi's connection with Mexico. Bill Ward, one of my friends who eventually became my best man when I got married, I had studied these rocks, and his first master's student, when he came to the University of New Orleans, did a pretty serious analysis of them. What they found didn't really make much sense. In fact, some of the people that reviewed it thought Bill had studied the concrete they drilled through rather than the rocks themselves, but Bill was far better than that. Just didn't make a whole lot of sense, so they found things that they couldn't understand. Years and years later, Walter Alvarez was traveling around the world and had seen a chemical appearing, a rare element that was only found in outer space at just the time period where the dinosaurs died out. It's called the KT boundary, the end of the Mesozoic time period. He went looking for where there might be something from outer space that had a big enough impact to kill off the dinosaurs. And they found a 100-kilometer wide crater underneath the Earth, not visible from the surface because it had long been covered over, but found it through seismic studies in northern Yucatan Peninsula, the Chicxulub crater. But the geophysics, looking down into the earth with seismometers like ultrasounds into a Mother Earth's belly, gives you some ideas, but they wanted to look at the rocks. So he went to Pemex first because he knew they drilled some wells down there. Unfortunately, where they'd stored the rocks from those wells, it burned down. But Walter Alvarez began looking around and found the master's thesis that Bill Ward's student had done on those very rocks. And so Walter Cronkite from CBS News did a special on dinosaurs later in his career, came to the University of New Orleans, peering around looking for the lost rocks that were from the time period of the dinosaurs. They were there at the University of New Orleans. He shone a flashlight as if we'd not paid our power bill for a while. A little bit of drama for TV. But those rocks, Bill went back and looked at years later and found evidence of things like shards of gypsum encased in glass. Well, glass forms when quartz cools very quickly, like when it's thrown up in the air. Gypsum is really, really soft. It doesn't poke through glass. So if the gypsum was thrown up at the same time and the glass solidified around it, that would explain those shards of gypsum inside the glass. They also found glass tektites over in Haiti and places like that. Lots of other pieces of evidence came together. But those rocks stored at the University of New Orleans helped support the story that the dinosaurs were killed by a big impact from outer space that hit right in this area, the Chicxulub crater, threw up lots of ash into the atmosphere, threw a tidal wave across the Gulf of Mexico, created big fires in North America, and made life unbearable for most of the dinosaurs. If we look at the ancient rocks in the world, what we see is that the interior of continents are where we find the very oldest rocks. If you remember when we talk about plate tectonics, we talk about how this area represents the tearing apart of these continents. Well, what helped support that story was recognizing the old rocks that corresponded across the Atlantic Ocean where they'd been ripped and moved apart. And along the edges of the continents, like North America, on each side, we find younger and younger rocks where plate tectonics adds those younger rocks to the surface. Let's focus in a little bit more on the United States. What we see along here is the Atlantic plain is mostly mushy stuff, sand and mud that got washed off of the higher rocks down towards the Gulf of Mexico and the Atlantic Ocean. We see very old rocks in the Appalachian highlands, the Appalachian mountains, that would have worn down in time, except for the isostatic rebound that we'll talk about a little bit later. Flat part within the Midwestern part of the United States, those interior plains, very flat, sculpted by glaciers and by outwash from the Rocky Mountains rising up to the west. The uplands here are where we can find the oldest rocks in the United States. I've been just north of Lake Superior and seen billion-year-old rocks. Many of the old rocks have been scraped clean by the glaciers. Over here we have the youngest, and then the next youngest, and the next youngest rocks that have been bowed up and pushed up and formed. As along here we have volcanoes still forming new rock. One of the questions we might ask is, how is the making of underwear in North Carolina related to geology? One of the things I love. Well, in the old days, hundreds of years ago, if we wanted power, we used water power to turn water wheels. And so all along this green line here, we go from relatively hard rocks, the Appalachian Plateau, down to soft sands and muds of the Atlantic coastal plains. And every river that comes from the Atlantic Ocean up into the mountains crosses over this boundary, the fall line, where there are waterfalls or at least rapids because of the hard rocks spilling, the water spilling off the hard rocks onto the coastal plain. So that was a great place to put water wheels that were used to turn the looms that produced the cotton that we sold to the world. We grew the cotton more down in here, so that's a different story. This nice flat land, warm, even up into this area here, was a much better place for growing cotton. North Carolina, where I grew up, was great for growing tobacco. Why aren't those jobs there anymore? When I grew up, Hanes Underwear was one of the main employers in the particular area, tobacco being the other one. Those jobs have gone overseas because of two reasons. One, communication and transportation is really cheap now, and the other is that labor is expensive. So it's cheaper to make them in Sri Lanka or India or China or something like that and ship them over than it is to pay labor to produce them here in the United States. Focusing in a little bit further into Iowa, what we see is that the oldest rocks are near the surface up at the northeast, and then we move towards the southwest to get younger and younger. That's because they lay over each other like in this diagram. Here's the old ones down near the bottom, the Cambrian. Here's the Ordovician above them. Here's the Silurian, just a little sliver, and then the Devonian on up, and then we have a little bit of yellow across the type here. That's the Pleistocene, that skin left by the glaciers across the top. That dipping down, a little bit of a bowing down of the rocks means that as we've eroded them down, the oldest ones are sticking up towards the Iowa-Minnesota border, and but are down underneath when we go over towards the southwest. The idea of the way in which things change over time, the processes, and the growth of the idea that became uniformitarianism came from James Hutton. And he stood for days, weeks, looking at these rocks at Sicker Point in Scotland. A few things to notice. Notice how these rocks are oriented this way. These rocks are oriented this way along here. Notice how there's erosion of some of these layers across here. James Hutton noticed these patterns, and then he looked a little bit closer and he saw chunks of these rocks that were inside of these rocks. And then he noticed chunks of these rocks that were out in the ocean. And he put together the idea of uplift and erosion, deposition, and cycling back in, uplift, so that this idea of this process that formed these, and this process that formed these, and the process that's going on today are all the same. A uniformity of processes through time. Uniformitarianism then looks at present-day processes, present-day patterns, and tries to understand what's gone on in the past. If you look at this erosion in a field today, from lots of rain falling, running off, down, and you look at the Grand Canyon, erosion is the process that helps us understand how the Grand Canyon formed over lots and lots of time, just like this is forming over a short time. Same process. Let's focus out a little bit on the big picture. We'll do a lot more on plate tectonics a little bit later, but the key part on plate tectonics is just to remember plates come together, pull apart, and slide by each other. There's just a few big plates and lots of little bitty ones. The oceanic ones go underneath the continental ones, and when they do, we get volcanic belts like the Andes Mountains along here. They part in the middle of the oceans. They slide by each other like in the San Andreas Fault right up in here. And so understanding these plate tectonic movements help us understand the location of volcanoes and earthquakes and oil deposition and all sorts of things the geologists use to make sense of the world. The plates move at about the rate your fingernails grow, about 4 inches per year. One of the ways that we know about this is by looking at the hot spot at Hawaii. This little area right here is blown up into here. This is the big island of Hawaii here. We have Oahu up in here. These numbers on here are the ages of the rocks And as if you notice and look a little bit more closely, as you move along this mountain chain and it goes underneath the water here, the ages get older and older. What we believe is happening is the Pacific plate here is moving along over a hot spot from the mantle, which is essentially burning its way up through the crust. And as it does, we can age date the rocks. We know how far apart the islands are, and that gives us a distance and a time, which gives us a speed or a rate at which the plate moves. It also gives us a prediction. If we believe the plate is moving, sliding along, then the newest rock ought to be forming down this way. And if we get in our little submarine and go down to the bottom, we can see a new island underneath that's starting to work its way up towards the surface. Where do we see ancient ocean bottoms nearby? I took this picture standing on top of it up north of Lake Superior, where the rocks have been scraped clean by the glaciers. Notice this pattern. This is what's called a pillow basalt. And if we can go in our submarine today down to the center of the ocean, we can see spewing out of a volcanic rock at the mid-oceanic spreading centers, right like this. And it forms what are called pillow basalts. Basalt, if you remember from geology lab, is a fine-grained mafic rock. It's cooled very quickly, but it forms kind of a rind like on bread at the bottom of the ocean. Okay, pause for another story that you can also find in the book. Evolution and antibiotic resistant bacteria. Evolution simply means change through time. It's a pretty easy concept to understand. If you're upset about it in terms of your religion, I'd be glad to talk to you. The Pope doesn't have any problem with understanding evolution. Presbyterians don't have any problem with evolution. They just don't think that tells the whole story. They believe the world is more than just materialistic. In terms of understanding antibiotic-resistant bacteria, it's pretty helpful, though. Everything varies. If you think about the members of your family, none of them look exactly alike. Even twins can tell each other apart, right? And so that variation, taller, shorter, also occurs in bacteria. Some are more resistant to antibiotics and some are less so. So here we have a bunch of bacteria from reproduction, and some of them are resistant, the red ones, and some are not so much. We give the antibiotics to the bacteria, kills off most of them, but there are a few that are left. Maybe you didn't take your antibiotics for the full 10 days that you were supposed to. Those two live there, and then you got a little bit run down, they start to reproduce. But this time, some are even more resistant, some are even less so, and you end up gradually breeding superbugs, bugs that can resist the bacteria. In fact, gonorrhea, which is a real common venereal disease before World War II, during World War II rather, soldiers would catch it, go back to the base, get some penicillin, which is fairly new at that time. Wouldn't always take it, go out the next weekend, catch another case of gonorrhea, go back, and within no time at all, antibiotic-resistant forms of gonorrhea were developed. So, same thing happens when any antibiotic is not used properly, doesn't kill off all of the disease. Next time it comes back even stronger than it was before. The selection process that was part of what we just mentioned can take a lot of forms in nature. Predation is one of them, where lions chase down and kill the weak, they kill the slow, whatever, so that the stronger, the faster live to breed and have offspring. The taller giraffe, the one that can reach up higher in the tree, has access to resources that the shorter ones don't have. So during times of drought, they can still get food where the shorter ones can't. Some organisms, such as cactus and such, have leathery, waxy coverings that prevent them to lose water, so they can prevent them from losing water, so that they can survive in harsh environments. And some organisms resist disease, such as sickle cell anemia helps resist malaria. So resistance to disease means that in certain environments, some organisms are going to live and some aren't. So all these things help determine naturally what's going to live and what's not, and particularly live long enough to reproduce. And that living long enough to reproduce means that they pass on whatever that trait was, like height for a giraffe, to the next generation. Whoops. So last thing, what's your reproductive strategy? Well, I do this in class, being kind of humorous, but the idea is this. Many organisms have just a few offspring, like the elephant, but nurture them. Some have lots and lots of offspring and don't nurture them. Both are quite successful in their own way. Which one are you going to be like? Lots of kids but not pay attention to them, or a few kids but take good care of them? You know which I prefer. Last thing, I want to remind you, when you see beautiful things in geology, like this is the lower Yellowstone Falls, gorgeous area. If you understand a little bit about the geology of how it forms, this is ash under here, this is a hard layer at the top of the waterfall, then it just makes it that much prettier, I think. Key points then: know those geologic time periods and have an idea about uniformitarianism and the processes by which things form, and know something about the stories I told, the death of the dinosaurs being one of those.